Come to the electrostatic challenge question number 2. In this question, we are getting a clear concept about the charge which is placed at the x-axis or y-axis. What is the nature of the electric field and how we can plot the graph. So 2 point charge Q1 and Q2 are placed on a axis. X is equal to minus a and x is equal to plus a. Plot the variation along the x-axis and y-axis. So to solve this, we have to plot the graph for every point. Every point means we have to plot the graph for the from infinite to minus infinite to plus infinite, and we have to approach from negative x to positive x. Okay, so here this is the, you can say this is the plus q charge and this is the minus q charge, and this distance is a and this distance is also a. This is obviously minus a. X is equal to minus a because it is the negative x. So if you say that this is the negative infinite and this is the positive infinite, so we have to plot the graph here, plus q charge and minus q charge. So we can split this position in the 4 part. Okay, 1, 2 are the nearer to the charge and 2 are the that is the infinite from the charge. Then we can exactly get the clear idea about the charge. Okay, so at we are approaching from negative to positive. So at minus infinite, what is the electric field? E is equal to k q by r square. So here r is equal to infinite, E is equal to k q by infinite, that is nothing but the 0. That means the E electric field at this point is 0. And what is the direction of electric field? The direction of electric field, as this is the nearer to the positive charge and the direction of electric field is in the direction, so that the electric field is, as it is negative direction, so the direction of electric field is minus I cap. That is the minus. That means that is the, it is the negative side. That means that it is the negative region. So here at infinite the electric field is 0. That means we can got this point here. Now we approach to the plus q charge. Okay, so at plus q charge we consider that this is a very small distance r and r is very less than 1. That means it is approaches to the 0 almost. So at r, so you can change the color, at r from a negative r from plus q. Okay, you have to calculate the electric field. So E is equal to, due to this charge, due to the electric field at this point is due to this charge and due to this charge. So is equal to k q by r square and minus k q by this distance is 2a plus r. So 2a plus r square. Now this r is tends to 0. That means this part is infinite minus this we got some value, and this is, you can say that is c. Now what is the direction of the field? So direction of the field is here, for this the direction of electric field is in this direction. Okay, so as the direction of electric field is in this direction, so this is the negative. So electric field at minus r, that is the approaches towards plus q, but before minus r distance is the positive in nature. So the electric field is infinite and it is positive in nature. So we can get another point which is at the negative side, but it is in the infinite. Now what is the relation between E and R? So E is proportional to 1 by r square, that is the rectangular hyperbola. So we can join the graph like this. Okay, we get the rectangular hyperbola. Now what is the electric field at plus q charge at a distance approaching towards the positive x? This is towards the positive x. So this is again r distance. So what is the electric field? So E from plus r for plus q charge, from plus r from plus q charge. E is equal to what? E is equal to k q by r square due to this field charge, and due to this charge it is minus k q by 2a minus r square, because this is a, this is a 2a, and this is minus r, so 2a minus r. So this part is nothing but the infinite minus something, that is the infinite, but what is the type of the charge. So for this part, the direction of electric field is in this direction, and for this charge also, that direction of electric field is also in this direction. Due to that, both are the positive, so we can get the point at positive infinite. Okay, you got it. Now at the center. Now at center, again you change the color. At center, what is the direction of electric field? K is equal to, first calculate the magnitude, k q by a square. At center, the distance is a, plus k q by a square. Why it is plus? Because at center, the direction of electric field due to this charge is in the direction. At center, the direction of electric field due to this charge, minus q charge, is also in the direction, because this is minus, this is, so electric field is towards the charge, and for plus q it is electric field is away from the charge, so both are in the positive direction, so that's why it is nothing but the 2kq by a square. This is the magnitude of electric field, and the direction is the positive direction, because both are in the positive direction. So you get one point over here, this point is, you can say that 2kq by a square. You got it? So again, nature of the electric field, that is the E is proportional to 1 by r, that is the distance inverse square. So it can obey the inverse square law. So we can join this graph like the rectangular hyperbola. Now at approaching to negative q. So approaching to negative q, that is the at for minus q, E, if this distance is r. So E is what? Again we change the color. E at minus q, r distance before. So the direction of electric field for this charge is in this direction, and direction of electric field for this charge is also in this direction, so both are in the positive direction. So at plus r, that is the at before the r distance, so E is equal to, due to this field, that is the k q by, this is 2a, this is k q, this is 2a minus r, so 2a minus r square, and as it is minus negative charge, minus k q by, this is the r, so r square. So as r is almost 0, so this become infinite. So c minus something minus c minus infinite is nothing but the infinite. And as the direction of electric field for this charge, it is in the direction, for this charge it is in this direction. So as both are the positive direction, so the charge is, that is the direction of the field is nothing but the positive direction. So here we get the again another positive plot, and again we know that what is the type of the that is the electric field, that is the, it is the nothing but that is the relation between the distance and the electric field is rectangular hyperbola, as it is inverse square law over inverse square law. So we plot the graph like this. So here third quadrant is also completed. Now due to q to here, now it is, if this is the plus r, what is the electric field for? So for minus q at distance plus r, okay, at distance plus r. So E is equal to what? For this, E is equal to k q by r square, and for this charge it is plus k q by 2a plus r square. So this part is nothing but the infinite. So infinite plus something is equal to infinite. So what is the nature of the charge? So for this, the electric field is in this direction because this is negative charge, and for this, the electric field for this charge, electric field is in this direction. So it is nothing but the negative direction. Sorry, for this charge, electric field is in the direction. So as this R is nearer to the negative charge, so this direction is predominant. So as this is the negative direction, so the direction is negative. So you can get 1 point, and as it is infinite, you get 1 point like this. Okay. Now at infinite, so at plus infinite, again we can calculate at infinite. It is simple. E is equal to nothing but the k q by infinite square, that is nothing but the 0. So and the direction of electric field at this point, the electric field direction is negative direction. So electric field is negative, and we can got another point like this. So as electric field and distance are the rectangle, that is the relation is the inversely square, that is it obeys the inverse square law. So this is the nature of the graph is rectangular hyperbola, and we can plot the graph like this. Okay, so this is the x-axis graph. Now if we go to the y-axis, this is most important. Okay, so we can erase it. We can erase it easily because we have to draw the y-directional graph. Now if we consider the y-directional graph, you see that there is nothing in the y direction, that is no charge is there in the y direction. So we cannot take any reference. We are not taking any reference. So we have to calculate it vectorization. So if we plot the, again we plot the quadrant for y-axis. So this is your positive y-axis, and this is your negative y-axis. Now at origin, for this is your plus q charge, this is your minus q charge. So at origin, we can take it at red color. At origin, what is the electric field? So due to this, electric field direction is in this direction, and the electric field direction for this charge is also in this direction. So both are add up. So this is the E is equal to k q by a square plus of k q by a square, that is nothing but the 2kq by a square, and you see the direction of the electric field is positive. So you can say that this point, you can take this point as 2kq by r square. Sorry, not r square, it is a square. 2kq by a square. So this distance is a magnitude. You can take this distance, you can say that this distance is y, because we have to plot, sorry, this, you can say take this distance as d. So we have to plot the graph for the y-axis. Now what should we do? We should know what is the electric field in this direction. So what are the electric field due to this charge at this point? The electric field at this point due to charge is away from the charge, and for this charge it is towards the charge, as it is the negative charge, as it is the negative charge, so it is towards the charge. So net electric field is nothing but in this direction, that is the, this is the 2kq, this is nothing but the 2kq by a square. Now at distance r, so what is that? So this is distance d, this is a. What is the this distance? This distance is nothing but the a square plus d square root under. So this distance, as this is the hypotenuse, so this is larger than a. So at distance a, what is the electric field? Electric at distance a, E is equal to what? 2kq by a square. Now so at distance root under a square plus d square, which is greater than a, the electric field is decreases. As distance increases, then electric field decreases. At distance A, the electric field is 2kq by a square, and the direction of electric field is positive direction. So at distance a square plus d square root under, as a square plus d square root under is larger than the a, so the electric field obviously decreases. So here we can get some point, we can take some point where the electric field is less than the 2kq by a square, something which is less than the 2kq by a square. Like that, here also, as the distance is increases, so electric field is decreases, and it is also 2kq by a square, the less than 2kq by a square. Okay, less than 2kq by a square for this. So we can get another point over here. Okay, so what is the, so here we can get 1 point, we can get 1 point over here, we can get 1 point over here. So if you plot the graph at y-axis, so this is the graph is like this. So we can, so this is the graph for y-axis. So if we shortly we can get the graph. So the nature of the graph is like this, and for x-axis the nature of the graph is like this. Okay, I think you understand this question. This is very conceptual question. See you in the next challenge.